Hi, my name is Siddhanta here, and this is our final project for the course Digital Signal Processing. Our project is called Vocal Extractor. The contributors are myself and Shikhar Vesh. Let us talk about the objective for this project. The main goal was to use signal processing techniques learned in the course and build something real life oriented to it. The application presented here, as the name sounds, Vocal Extractor, executes predefined audio processing algorithms to extract vocal and instrumental audio signals from a song. And finally, we get two resultant wave files, one for vocals and one for instrumentals. Some of the tech stacks used for this project include Python, Python and Tkinter, PyAudio Analysis, Pygame, Matplotlib, NumPy, and Librosa. Let me give you a quick demo for the app. This is the GitHub repository for our project. As you can see, there are two folders called images and songs. The songs folders has two example wave files which you can use. Then we have the PDF report, and you can look around and see how and what we have done and all the details. Then we have the main.py, which is the main function, and then requirements.txt contains all the requirements and dependencies to run this program. You can git clone this project. I have already done so, and let me show you how it works.
The project is entirely written in Python and makes use of several famous libraries such as Tkinter and Pygame for GUI, NumPy and Librosa for audio processing tasks, and PyAudio and Matplotlib for real-time audio visualization and playback. Our goal is to extract vocals and instrumentals of the project. So this extract function over here is helps us execute our tasks. It makes use of Librosa functions NN filter and applies soft mask on the given audio input. This soft mask function combined with our custom parameters and NN filter generates us two audio tracks called background and foreground, as we have defined in our variable. This audio track is the final generated output, and this eventually gets saved in the songs folder, so the software can play back the output in real time. Next up, we also have the real-time visualization. This graph function is based on one of our homework submissions, and it loads the audio track in chunks or blocks and processes the output by passing it to Matplotlib in real time. So
this is our main application. We have a menu from where we can add a single song, or we can add multiple songs. We have a volume slider control from where we can control the volume. We have a play button which will play the file, a pause button which will pause the file, a stop button which will stop the file and deselect the file. We have the main play button, mic button, which we are using for the main function. This function extracts the vocals and instrumentals, which is the main function of our project. And this is the graph visualizer button from which we can visualize the wave file. Let us just add a song and let me show you how it's done. As you can see, I have added Blinding Lights by The Weeknd. You can set the volume. Let me just play this once. As you can see, it works perfectly fine. I can stop to deselect the file. Let me get the instrumental part as well as the vocal part for this by clicking this button. And this button runs a code which generates two files, namely Blinding Lights vocals and Blinding Light instrumentals. The vocals part has only the vocals, and the instrumental parts has only the instrumentals. Let me run the vocals file and show you how it sounds. Similarly, let us hear the instrumental file. As you can see, the instrumental file does not have vocal, and this is pretty accurate. As you can see, the waves are bigger for the instrumental. And let me visualize the vocals too. As you can see, the vocals part were almost flat when the instrumentals were there and not vocals were there. That means the instrumentals have been removed to quite an extent. And you can close the file, and this was our project. Thank you, and make sure to use it and let me know how you find it.